Hi, and welcome to another episode of McClatchy Maths. My name is Natalie McClatchy, and today we're going to be talking about factorising algebraic expressions. This is for grade 9. We're going to be starting with some very basic algebraic expressions that we're going to factorise and move on to doing this with DOPs. As always, you can contact me at mcclatchymaths@yahoo.com. And I'm dedicating my video today to my future holiday in the USA. Shout out to all of our tourism workers at the moment who are all wondering if it's ever going to get back to normal. Fingers crossed, I'm still dreaming. Let's go. Okay, so quick recap. You should have watched my previous video on how to expand, which means to remove the brackets. The opposite of expanding is factorising. That means we're taking an expanded expression and putting it back into the brackets. These are the reverse actions of one another, and that's important to note because we can always use one answer to check the other, which we're going to do in this video. One thing I should warn you is whenever you see negative numbers, you should always put your thinking cap on and be wary. Negative numbers are always something we need to be very careful of, remembering our rules for multiplying and dividing. Positive times positive gives positive. Positive times negative gives negative, and negative times negative gives positive. So just remember our little rules. When you see the subtraction sign, just put that thinking cap on and be wary. Something else to be aware of when we're factorising, what we're meaning by this is we're looking at all the terms in an expression and we're looking for that highest common factor. That highest common factor could be part of a coefficient and part of a pronumeral. So we need to look at all the different terms and make sure we've factorised it fully. So just remember, look at your numbers at the front and your letters at the back, look for what they've got in common. That's our highest common factor. I'm going to show you some examples now. Let's look at example 1. Factorise 9b plus 12ab. Well, my very first step is to look at the coefficients 9 and 12 and work out what the highest common factor of these is. It's 3. Now, I'm going to look at the pronumerals a and b. What's my highest common factor of these two? Well, of course, it's b. So my highest common factor overall is going to be the combination of 3 and b, or 3 multiplied by b. That's going to be 3b. That will go on the outside of a set of empty brackets, just like this. So you just write with enough space to put the rest of the information inside the brackets once you're finished. Now, my next step is to go back to my first term, 9b. I need to ask myself a question. 3b, which is that highest common factor, times what will give me 9b? Another way I could think about this might be take that first term, 9b, and divide it by that highest common factor, 3b. What's going to be my answer? Well, the answer is going to be 3. 3b times 3 gives me 9b. That becomes the first term on the inside of those empty brackets, just like this. Now, I followed the same process again with the second term, 12ab. Ask yourself, 3b times what gives you positive 12ab? And I've put the positive sign there because that's a good practice to get into, especially when you're using negative numbers, which we don't have to worry about in this question. Ask yourself, positive 12ab divided by 3b. Well, what's the answer for that? That's going to be our second term inside the set of brackets. It's positive 4a. So we pop that in the brackets and we're almost finished. Okay, I've noticed I've said it's done, but we should always check our work mentally by doing the opposite, which is expanding. So now looking at these sets of brackets, well, 3b times 3 is 9b, correct? And 3b times 4a is 12ab. Also correct. I know I'm done and I'm ready to move on. So let's look at example 2. 4x squared take away 16xy. Now straight away I can see that subtraction sign. That's a little warning bell for me that I need to be a little bit more careful this time. And I'm going to follow the same process again. Looking at the coefficients 4 and 16. What's my highest common factor? It's 4. Looking at the pronumerals, x squared and xy. What's the highest common factor? It's x. So the combination of 4 and x, 4 times x, is my highest common factor. It's going to be on the outside of an empty set of brackets. So it'll be 4x and then brackets with some space for me to write inside the brackets. Now, I'm going to look at the first term from my start of my question, 4x squared. I'm going to ask myself those questions again. 4x times what gives me 4x squared? That would be x. It goes inside the brackets. Now notice I've got that negative number. Positive times a negative. I've got the positive at the front of the brackets. So times a negative, I'm going to have a subtraction sign inside the brackets. So I've got negative 16xy. Well, 4x times what gives me negative 16xy? Well, of course, that second term inside the brackets will be 4y with the subtraction separating the two terms. And I'm not quite done until I've done a mental check. So I start again, 4x times x, 4x squared, good. 4x times negative 4y gives me negative 16xy, also good. Ready for the next example. Example 3. Now, whoa, I've already got some brackets here. That means the job's partly done for me, which is fantastic. So I just need to remember that when I see it like this and I'm told to factorise, to read the question really carefully. Some people are just tempted to expand straight away as soon as they see brackets are already there. Make sure you read the question. It's still telling you to factorise, which means I'm halfway there. I've got to finish the job. So looking at those now, I can see that the first set of terms, 4 brackets x plus 3, has in common with it x plus 3 in that second set of brackets as well. So that is my highest common factor. And just like the previous example, the highest common factor goes out the front. So I'm going to have x plus 3 out the front with an empty set of brackets at the end. Now, in that second set of brackets is everything that was outside the brackets to begin with, because they were already multiplied by the highest common factor. So 4 plus x is going to fill that empty set of brackets. Now, I could expand this out and check my work, but what I'm going to end up with is an expression with 3 terms in it, and it's going to look nothing like my starting point. So a better way of doing this is just to check x plus 3 is at the highest common factor. It's at the front. Yes, it's common to both. And then just check that everything that outside those brackets has been put inside the brackets carefully, especially if I've got negative numbers. Let's look at example 4. This one's a little bit different. I'm looking at this, I'm going, whoa, there's nothing in common. There's no common pronumeral. There's no common coefficient. What do I do? Well, I need to have a bit of a think, because if you remember from our last video when we looked at factorising trinomial or binomial products, then I've got difference of perfect squares and perfect squares I need to think about. It could be one of these. Have a look there. I can see down the bottom, it fits that form. So when I'm also coming to a position where I discover that there's no common factor in between the two and I'm told to factorise, I need to remember that it could be this situation, a DOP situation. So what I'm going to do now is look to see, are they 2 squared numbers subtracted by each other? And if that's the case, I'm going to put it back into its original form. So let's do that. Are they both squared numbers? The answer is yes. X squared is x squared, and 49 is 7 squared. And they're both separated by a subtraction sign, and that's also very important. If it was separated with an addition sign, I wouldn't be able to do this. So I'm going to be able to put it back into DOP's form. So I take the square root of the first term, x squared, and I put it into 2 sets of brackets, and I leave some space for the rest of my answer. So I've just got x, x. And then I'm going to put a plus sign in one set of brackets and a minus sign in the other set of brackets. And then lastly, I'm going to take the square root of the second term, 49, which is 7, and put that into both sets of brackets. Now, the best way to check this before I walk away is to expand x plus 7, x minus 7. I could use my rule and double check it, or I could use FOIL, first outside, insides last, and get it back to x squared minus 49, and then I would know I was done. Let's do this one more time with a slightly more complicated situation. Example 5 is 3x squared minus 108. Now, straight away, I'm going to look at this and go, oh, I've got a squared, I've got a takeaway, maybe I can use DOPs. But hang on a minute, the coefficient 3, that's not a squared number, and neither is 108. So I've got to go back to my original way of doing things and find the highest common factor, which is going to be 3. I put that outside the brackets, and inside the brackets is the rest of my information, x squared take away 36. Now, a lot of people will just stop there and they won't go any further. They'll just think, okay, I factorised it, I'm done. However, there is another step that you can follow, because look inside the brackets. We've now got a DOP situation. So I'm going to follow the same process there. I'm going to factorise that. I take the square root of x squared, which is x, and the square root of 36, which is 6, and I separate those into 2 sets of brackets. And now I'm done. And of course, I should always check my work before I move on. I hope you found this really helpful today. Thanks for listening, and do like and subscribe to the channel, and keep on dreaming about your Disneyland dream or your future travels. Have a great day.